So good morning to all of you. My name is Prabjot Singh, and as you have already seen the working presentation of my PWM model, so now let me explain you that how it was working. So let's get first to our basic model. This was my how I designed my project. So here's an LED resistor, and it is connected to the GPIO 4 of the Raspberry Pi, and the 5-volt output and the ground was here. And here sorry for that, I stick my ultrasonic like this because it was soldered and there was no place to stick in breadboard. So let's get this is a basic design I have made to explain you that this is the 5-volt output I have given to my ultrasonic and the ground, and this ground also goes to the LED, which is also connected, whose positive terminal is connected to GPIO 4, which I will show in the code, and the echo and the trigger are connected to GPIO 20 and 21 respectively, which are here, these GPIO 20 and 21, and LED is here GPIO 4. So now let's get to the code. So here's the code of my this working model. So here I have imported the GPIO. These are basic thing. Then this is for only avoiding the warnings. Here I have defined my trigger pin, echo pin, and the LED pin. Then I have set it to BCM so that I can use the GPIO numbers, and then I have set up the LED pin. And now here comes the main concept of the PWM, that how my LED was getting from 0 to 100 and 100 to 0, because this is how we set the LED to 100, and now at start I have set the LED to 0%, that when it is out of the range it will be 0%, and now I have created an array of 100 to 10%, that percentage of brightness of LED, which I will tell you about later. Then I have started a while loop, and here's the code of like I have set up a trigger pin and echo pin for in and trigger for out. Then here the trigger pin, here are some formalities that trigger we ensure that trigger pin is low, and then some sleep time. Then there is a while loop where the echo pin detects that there is an echo or not, which is sent by the triggered pin for only 10 microseconds. And then the pulse end time and the pulse start time defines the pulse duration, which is then multiplied by this number, which is the speed of sound, sorry for that. And then I have rounded off my distance into the multiples of 2, because I have to get the data in the multiple of 2, as I have set these percentages like for 20 centimeter 10%, then 18 20%, then 16 30%, up to 2 centimeters 100%, that here is the maximum range it is achieved. And then here this is how I print the distance, and here is the main code which defines that how much brightness should the LED show, as when the distance is bigger than 0 and less than 20 centimeters, then the index will be distance minus 2 divided by 2, which basically means that it will get the index of that array. Like if the distance is 18, then 18 minus 2 is 16, by 2 8, which means this one 30%. So 18 centimeter means 30% of brightness. Then sleep of 1 second, that it will update after 1 second. So this was how it was working. I hope you all understand. Thank you and have a nice day.